A microcontroller, MCUC or MC, or microcontroller unit, MCU, is a small computer on a single integrated circuit. A microcontroller contains one or more CPUs, processor cores, along with memory and programmable input-output peripherals. Program memory in the form of NOR flash, OTP-ROM, or ferroelectric RAM is also often included on the chip, as well as a small amount of RAM. Microcontrollers are designed for embedded applications, in contrast to the microprocessors used in personal computers or other general-purpose applications consisting of various discrete chips. In modern terminology, a microcontroller is similar to, but less sophisticated than, a system on a chip, SoC. A SoC may include a microcontroller as one of its components, but usually integrates it with advanced peripherals like a graphics processing unit, GPU, a Wi-Fi module, or one or more coprocessors. Microcontrollers are used in automatically controlled products and devices, such as automobile engine control systems, implantable medical devices, remote controls, office machines, appliances, power tools, toys, and other embedded systems. By reducing the size and cost compared to a design that uses a separate microprocessor, memory, and input-output devices, microcontrollers make digital control of more devices and processes practical. Mixed-signal microcontrollers are common, integrating analog components needed to control non-digital electronic systems. In the context of the Internet of Things, microcontrollers are an economical and popular means of data collection, sensing, and actuating the physical world as edge devices. The first multi-chip microprocessors, the four-phase systems AL1 in 1969 and the Garrett I Research MP944 in 1970, were developed with multiple MOS LSI chips. The first single-chip microprocessor was the Intel 4004, released on a single MOS LSI chip in 1971. It was developed by Federico Faggin using his Silicon Gate MOS technology, along with Intel engineers Marcian Hoff and Stan Mazer, and Busicom engineer Masatoshi Shima. It was followed by the 4-bit Intel 4040, the 8-bit Intel 8008, and the 8-bit Intel 8080. All of these processors required several external chips to implement a working system, including memory and peripheral interface chips. As a result, the total system cost was several hundred 1970s US dollars, making it impossible to economically computerize small appliances. MOS technology introduced its sub-$100 microprocessors in 1975, the 6501 and 6502. Their chief aim was to reduce this cost barrier, but these microprocessors still required external support, memory, and peripheral chips, which kept the total system cost in the hundreds of dollars. Microcontrollers have transformed the landscape of electronics since their inception in the 1970s. The first microcontroller, the Intel 4004, was a groundbreaking innovation, integrating a CPU, memory, and I/O functions on a single chip. This compact design paved the way for embedded systems, allowing engineers to create smarter devices. As technology advanced, we saw the rise of 8-bit, 16-bit, and eventually 32-bit microcontrollers, each iteration offering increased processing power and efficiency. The introduction of the PIC and AVR families further democratized microcontroller use, making them accessible for hobbyists and professionals alike. Today, microcontrollers are everywhere, from household appliances to sophisticated robotics, driving the Internet of Things revolution. Their evolution reflects our relentless pursuit of miniaturization and efficiency, making them essential tools in modern engineering. Understanding this history not only highlights their significance, but also inspires us to innovate further in this dynamic field.